Have you ever looked up at the night sky and wondered how the heck we stay stuck to the ground? As long as we don't step off the planet, it seems like gravity just keeps us nice and grounded. But have you ever noticed that your weight changes depending on where you are? And when you jump up and down, you actually do start floating away from Earth, even if only for a few seconds. Well, in this video, we're going to look at what the science has to say about gravity, so you can better understand this force of nature that keeps you down to Earth. If you've taken physics courses in high school or college, you probably remember Newton's law of universal gravitation. This law states that every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Okay, that was a mouthful. But what does it mean? To put it simply, everything in the universe pulls on everything else. You and I are made of particles, and so is the Earth. All these particles are pulling on one another, but the effect is cancelled out because they're so close to each other that the forces are equal and opposite. However, since you and the Earth are much closer to each other than you are to all the other particles in the universe, you and the Earth exert a gravitational force on each other. Since you are so much less massive than the Earth, the gravitational force you exert on it is relatively small. But the Earth exerts a huge gravitational force on you. This force we feel as our weight. So although we're really falling around the Earth all the time, we do want to go flying off into space. Because the Earth's gravity keeps us firmly planted on the ground. But have you ever wondered, why does gravity exist? Well, scientists still aren't sure. If you ask Albert Einstein, he might tell you that the answer lies in the curvature of space. According to Einstein, massive objects like the Earth warp the very fabric of space and time around them, and this warping creates what we perceive as gravity. If that sounds confusing, don't worry, it's really complicated. But the bottom line is that there is nothing really keeping us down to Earth except the curvature of space. Now, that may not be the most satisfying explanation, but it's probably the best we'll get for a while. Scientists are still working hard to develop a theory of quantum gravity that would explain how gravity works at the atomic level. Until then, Einstein's theory of general relativity will have to suffice. And speaking of theories, there are lots of them when it comes to gravity. One of the most popular ones is the so-called fifth force. Proponents of this idea believe that there are actually 5 fundamental forces of nature, not just for the 4 we know and love are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The fifth force, if it exists, would be some kind of force that could explain the behavior of dark matter. Dark matter is a mysterious substance that makes up a quarter of the entire universe. We can't see dark matter directly, but we know it's out there because of its gravitational effects. Unfortunately, scientists haven't been able to figure out what exactly dark matter is, but some think that it might be made up of a new type of particle that's not affected by any of the 4 fundamental forces. If that's the case, then there must be a fifth force that's keeping dark matter bound together. Now, there's no evidence that the fifth force exists, but it's a popular idea among physicists because it would help solve some of the problems with the Standard Model. The Standard Model is the best theory we currently have for how the universe works. It describes all the known particles and forces of nature except for gravity. So if we could find the fifth force, it would be a major scientific breakthrough. But even if we never discover a fifth force, that doesn't mean that gravity isn't real. In fact, there are plenty of real-world examples that show how important gravity is. For example, gravity is what causes tides on Earth. When the moon passes overhead, its gravity pulls on the water in the oceans, causing them to bulge up. This bulge is what we call high tide. As the Earth rotates, different places experience high tide and low tide as the water sloshes back and forth. But it's not just the moon that affects the tides. The sun also plays a role. During the summer, the sun is higher in the sky, and its gravity has a greater effect on the tides. This is why we experience higher high tides and lower low tides during the summer months. Gravity is also responsible for the rings of Saturn. These rings are made up of countless small pieces of rock and ice that range in size from dust grains to house-sized boulders. The rings are so delicate that they could be destroyed at any moment by a meteoroid or comet, but somehow they've managed to stay intact for billions of years. The secret, it seems, lies in the balance between gravity and angular momentum. Angular momentum is a measure of an object's tendency to keep rotating. The faster an object rotates, the more angular momentum it has. Saturn's gravity keeps the rings from flying apart, but the objects in the rings must also have some angular momentum in order to keep rotating. Otherwise, they'd all eventually crash into each other. The delicate balance between these two forces is what keeps the rings of Saturn intact. But perhaps the most important thing to understand about gravity is that it's a force that brings things together. From the smallest particles to the largest galaxies, everything in the universe is held together by gravity. Without gravity, the universe as we know it simply couldn't exist. On Earth, gravity gives us a sense of stability and connection to the planet. It's what allows us to walk on the ground without falling through it, and it's what makes it possible for plants to grow and animals to live. Of course, too much gravity can be a bad thing. Living on a planet with an extremely strong gravitational pull can make it difficult to move around, and too little gravity can be just as problematic. If we were on a planet with a weak gravitational field, we wouldn't be able to walk very well, and everyday tasks would become challenging. But on the whole, gravity is a good thing. It's a force that brings us together. It holds our planet in orbit around the sun, and it keeps us grounded when we're feeling lost. Now, we may not be able to change the strength of the gravitational field around us, but we can change how we respond to it. Next time you feel like you're being pulled down by your circumstances, just remember that you have the power to rise above them. Just like the planets and stars that seem to defy gravity, you can achieve anything you set your mind to. Of course, you'll need a lot of hard work and determination to make it happen, but it is possible. So don't ever give up on your dreams. On that note, we're gonna wrap up this video. But before we go, we want to thank you for watching. If you enjoyed this video and learned something new, be sure to hit the like button and share it with your friends. And if you haven't already, subscribe to our channel so you never miss an upload. Thanks again for watching. We'll see you next time.